So greetings, dear students, the teachers and everyone who is here today with us. So I greet you all members. So can I see some reaction from the members to confirm that we are surely here? You can give us a sum. Please confirm your presence. It is very important. So I shouldn't assume that members are here when they are not. Okay, so members around, all right. Okay, so for those that might be here for the first time, TV is my name, and I will be taking you through this mock here. This is Principal Mathematics Paper 1 from Uganda Teachers Education Consult, and that is Utec. For those that might have been here yesterday, we looked at item number 1 for this same paper, and in case you missed that, then please you will find the video on our YouTube channel. The video is being uploaded, and so you can easily watch it at any time from now. And today we shall be looking at item number 2 and item number 3. So our focus is to at least look at the 2 items. Yesterday we looked at the first item, which is from section A, and today we would like to add there 2 more items. At least we complete the 2 items from section B, part 1. So this is the paper that we are discussing. Although we realized that some items are not clearly seen, so we have the copy here, which we shall be using. So this is item number 2, and that is from section B, part 1. So without wasting time, we shall go through this item together. Then we look at the proposed response, and if there should be any adjustments, we should as well look at that together here. So this is what the item was all about. So the item was saying that your neighbor is planning to start a fish farming business. He attended a workshop concerning fish farming, and he was told that fish grows very well if the pond was of the right measurements. The right lengths L, width W, and height H, all measured in meters for the pond. For every n, that is in thousands fingerlings, given by L plus or minus W square root of H, obtained by dividing the number n of fingerlings to be put in the pond by the magnitude of the square root of this one here. The neighbor plans to start the 4,000 fingerlings. Due to limited space, he wishes that the size of the pond to start with does not exceed 20 meters cubed. Okay, now should not exceed 20 meters cubed for the available space to be enough. If it exceeds this capacity, then he will have to reduce on the fingerlings to fit in the available space. Next, we are told that he has also been told that the profits P in millions from this business depend on the number n in thousands of fingerlings sold per harvest. He has been told that these profits equal to the ratio of the fingerlings increased by 2 or divided by the square of the fingerlings less 5 times the fingerlings and increased by 6. He wants to determine the range of fingerlings that will give him at least 1 million shillings per harvest to establish whether his choice of starting with 4,000 fingerlings will be feasible. He has also been told that the cost in hundreds of thousands for farming n in thousands fingerlings is given by dividing the number of fingerlings with the magnitude of principal argument of the complex number z, which z is here. He wishes that the cost does not exceed his planned budget of 300,000. If it does exceed, he will reduce on the fingerlings. Here is the task. Help your neighbor to make an informed decision before starting this business. So basically, that is the information that we are given. And since this is a block question or a block task, then we need to divide. We need to divide our scenario into different parts so it can become easier to handle this scenario. So we are told we shall first of all read again to understand what we should basically begin with. So we are told your neighbor is planning to start a fish farming business. He attended a workshop concerning fish farming, and he was told that fish grows very well if the pond was of the right measurements. The right length L, width W, and height H all measured in meters for the pond, for every N. N is in thousands. These words are very important. N is in thousands. Fingerlings are given by this one here, which is obtained by dividing the number N of fingerlings. So we obtain this by dividing the number N of fingerlings to be put in the pond by the magnitude of the square root of 14 plus 6 square root of 5. The neighbor plans to start with 4,000 fingerlings, but due to limited space, he wishes that the size of the pond to start with does not exceed 20 meters cubed. So in other words, our task is to find out whether the size of the pond will not exceed this. And if that one happens, then it means the available space will be considered to be enough. But if it exceeds this capacity, then he will have to reduce on the fingerlings to fit in the available space. So our part 1 should be lying here. So looking at what we need to first of all look at what is the size of the pond. Does that size exceed 20 meters cubed or not? And that will give us the reason to make our conclusion. So this would be acting as the first part for our scenario. So from this part, we should now be in position to give our conclusion, and we help the neighbor to make proper decisions. In case you have any information, please put it in the chat box. I will always be checking through, and for that, we shall be able to move at the same pace. So let us look at the response to that. Let us look at the response to our first part, and that is the first part of the scenario. Now we are saying for our first part, so to look at the response for item 2, we shall first of all try to analyze the given information. So for the part 1, this is what we are told. We are told that the right length L, width W, and height H all measured in meters for the pond for every N which is in thousands. You need to note that fingerlings are given by this, but this is obtained by dividing the number N. You divide the number N, okay, by the magnitude of the square root of this number. This is what we are having. That this one here is actually obtained is equal to N divided by the magnitude of the square root of the complex number that we are given, of this side here that we are given. That is 14 plus 6 square root of 5. Now, since we are given this information here, we are told that length is represented by L, width by W, and H represents the height. All these are in meters. and n is the number of fingerlings in thousands. So that is the information that we have. But we are told that we are starting with the starting stock is 4,000 fingerlings. So it means since n is given in thousands, then it means our n will be equal to 4. Then what is the space constraint? We are told that the pond volume must not exceed 20 meters cubed. Then this is the information which we shall use to look at the first part. So this is generally the information that we have. Someone is saying the screen keeps on disappearing. Please confirm to me if the screen is visible. Because the screen seems to be okay, but I think some are finding it a bit challenging. So is everyone able to see my screen? Okay. So they are saying the screen is okay. So maybe it might be a personal problem. Maybe your network is not all that good there. All right. So we are saying this is the information that we are given, and that is the information to the past in the first part. This one here, the right length L, then width are all measured in meters, and we are told for every this one here are all measured in meters for the pond for every n. And this is given by this, which is obtained by dividing the number n to be put in the pond by the magnitude of the square root of this number. So that is why we are having this. So to obtain this, you must have n divided by the magnitude of the square root of 14 plus 6 square root of 5, where L, W, and H are measured in meters. And n is the number of fingerlings in thousands. So it means if we are starting with 4,000 fingerlings, then it means our n is 4. So we need to obtain the volume, and we are given the constraint that the volume must not exceed 20 meters cubed. So can we get the volume? To get the volume, we must have length, we must have width, we must have the height. So let us look at how best we can get that. So that is our first part that we are looking at, and that part we shall be talking about the pond dimensions and the space feasibility. Now here, they are telling us, when you read through that scenario, they are basically testing your knowledge of whether you are able to simplify the SADs, and if you are in position to deal with rationalization of SADs. So what we need to do is we must express this one here in the form of a plus b square root of 5. Then after we use it to simplify the given ratio at n is equal to 4. From there we identify the L, the W, and the H by comparing the rational and irrational parts, and then we compute the pond's volume to check the space condition. So that is basically what we shall be doing. So one, we must get the square root of this. So this is the square root of 14 plus 6 square root of 5 is what we should get first. So how do we get that? So what we need to do is you need to recall that if you are looking at the square root of a number in the form of p plus q square root of k, then the square root of such a number will be of the form a plus b square root of k. If you want the square root of a number of the form, this one here, then the square root of this number will always be of the form a plus b square root of k, meaning that this one here that you have under the square root will remain the same, although the p and q, these ones can change, of course. So that's why we are saying you must always recall that square root of a number of such a format will always be of that form. So what we can do from here is we can let the square root of 14 plus 6 square root of 5 to be equal to a plus b square root of 5. Okay, so from this given point, you are letting this. So want us to solve that together. So let us work that one from here. Okay, all right. So I want us to look at that. We are interested in obtaining the square root. We are interested in obtaining the square root of 14 plus 6 square root of 5. And as we have said, when you are looking for the square root of a number of the form p plus q square root of k, then the answer will be of the form a plus b square root of k. So likewise, we want to let the square root of this to be of the form a plus b square root of 5. Okay, so from here we are interested in getting a and b. Now if the square root of this is equal to this, what we can do here is we can square on both sides. So when you do squaring on both sides, what will it give us? It will give us 14 plus 6 square root of 5. 14 plus 6 square root of 5. Okay, that is the same. So this will be, now you are squaring on both sides. So this will be a plus b square root of 5, which is squared. So when you have that, you can now do expand this. When you expand this, this will be same as a squared plus 2a times b square root of 5 plus b square root of 5, which is a squared. So I hope everyone knows how to expand this. So this is a squared plus 2ab square root of 5, then plus b squared times 5, that is 5b squared. So that is what we shall have. So this is 14 plus 6 square root of 5. So this will be of the form a squared plus 5b squared. Then we add there 2ab square root of 5. So from this given point, we can now equate. Because for this to be equal to this one here, then this should be equal to this. And since this is root 5, this is root 5, then 6 should also be equal to 2ab. So when you equate the corresponding components, then you should be able to have a squared plus 5b squared, which is equal to 14. You should as well be in position to have 2ab, which is equal to 6. We should be able to have that. Now, from that given point, I have these two equations. So I can simplify this to give me ab as 3. So I can have this as equation number 2. So from these two equations, we can now try to get the values of a and b. So from equation 2, I can make for example, b the subject. If I make b the subject, I will have b as 3 divided by a. From 2, I will have that. Now substitute equation star into equation number 1. If I do that, I will have a squared plus 5b squared, but b is 3 over a, which is squared, and this will be equal to 14. When we go on, we shall have this as a squared plus 5 times 9 divided by a squared, which is equal to 14. From this given point, you can now multiply a squared throughout. This will be a to power 4 plus 45, which is equal to 14a squared. So I can have this as a to power 4 minus 14a squared plus 45, which will give us 0. So how do I solve this? This is a to power 4, this is a squared. So what I can do is I can create a squared within this. So minus 14a squared plus 45, which will give us 0. So I can let, for example, p to represent a squared. If p represents a squared, then it implies that p squared minus 14p plus 45 will be equal to 0. So solve that. So let's solve that. When we solve this, we can use the quadratic formula. So p will be equal to, even without the quadratic formula, we can as well get the factors. I think that will be 9 and 5. So we can have that 9 and 5. So we can easily get the factors here. So that is p squared minus 9p minus 5p plus 45 is equal to 0. So I can put the p out. I remain with p minus 9. Then I open the same bracket, p minus 9. Then here I will put negative 5. And this is equal to 0. So what will this give us? This will give us p minus 5 into p minus 9, which is equal to 0. So I will have that. So from here, we shall be in position to get the values of p. So either p will be equal to 5 or p will be equal to 9. Now with that, remember T is the same as A squared. So this implies that A squared is equal to 5. And A will be plus or minus square root of 5. That is 1. Again, A squared is equal to, again, A squared here is equal to 9. So it means A is plus or minus, is equal to plus or minus 3. Okay? So that is what we are having. So someone is having a hand, is asking, isn't there? Okay? Someone has a hand up. Isn't there something you have left above? Yes, please, James. Yes, please.
Excuse me. Thank you, teacher.
Yes, please.
It seems on our first equation, which was equation 1, we had there 6 root 5.
6 root 5, yes.
When we are equating there.
Yes, yes. This and this.
Where did we leave it? Yes.
Which one? We didn't leave anything.
That's 6 root 5, which is...
No, I'm comparing. I'm taking the coefficient. This is root 5, this is root 5. So I'm picking the coefficient. This is 6, this is 2ab. Okay, you want us to say 2ab root 5 is equal to 6 root 5. The root 5 will still cancel. You get 2ab, which is equal to 6. So ab is still 3. Where is the confusion?
Okay, thanks.
Okay.
I have got you.
All right. All right. So let us go on. Now, members, we are having these values here. Before I reject the sum, we are having these values. A as positive root of 5. I want you to look at that. A is positive root 5. Then A can be negative root 5. A can be 3, or A can be negative 3. Now, let us use these values to get the value for B. Remember, B is this. For B equaling to 3 over A. For B equaling to 3 over A. It means that for A equaling to root 5, what will be B? What will be B? B will be 3 divided by root 5. We shall have that. And this will imply that now, remember what we need is this one here, is the square root of this to be equal to A plus B root 5. Okay? So if A is root 5, if A is root 5 and B is this, we need to go on and get what is A plus B square root of 5. This is same as having A root 5, okay, plus B. But when you look at this one here, when you look at this, this is A plus B root 5. So, which means we shall have root of 5 plus B, which is 3 root 5, then times A, times again root 5. So this root 5 will cancel, you remain with 3 plus root 5. You will remain with that, which means that the square root, of this one here, so far we have got 3 plus root 5. Now, I want us to look at another part. That is 3 plus root 5. That is the one of the square root. So it means we are having the square root of 14 plus 6 root 5 as 3 plus root of 5. But now look at the case when you use this minus here. When you use this minus, when you look at this one here, when you take your A as 3, then what will be B? So for A equaling to 3, then your B, remember, is same as 3 divided by A. So it will be 3 divided by 3, and this will give you 1. So this will also imply that the square root of 14 plus 6 square root of 5 is actually equal to A. Remember, it was of the form A plus B square root of 5. So this will be same as having A, which is 3, and then having b, which is 1, then times square root of that. So this will give us 3 plus square root of 5. But now, when you generally look at this one here, actually the numbers to discard are many. When you look at this, this is a, and a is supposed to be a number which is not under the square root. B is supposed also to be a number which is not under the square root, because a and b are not under the square root signs. So having obtained this, then you can also discard this. You can discard this. You can discard this, and you only go with a equaling to 3, which will give you b as 1, because this is where you are getting the values which are not under the square root. So you are supposed to consider a as 3 and b as 1. Okay, so which will give us the square root of this value as 3 plus the square root of 5. Though when you also use the one which is under the square root, you will as well get the same answer. I have a hand from Elvis. Elvis, are you asking or?
Master.
Yes, please.
I was confused on how you came up with 3 plus root 5.
3 plus root 5.
Yes.
Where? This one. This is A, this is B.
Are. Where we are having B equals to 3 out of root 5.
B is equal to 3 out of root 5. I substituted it back in A plus B root 5. So A is root 5. Then plus B is 3 over root 5. Then there is this root 5. There is that root 5 which will cancel with this. Then you remain with root 5 plus 3.
I've got you, sir.
Yes.
Thank you.
All right. But looking at this, as I have said, when you reach here, without going through all this, because you look at your A is root 5, is negative root 5. Your A is 3, your A is a negative 3. Now, this one here, of course, we have already discarded that. That is A equaling to negative 3. Then you have A equaling to root 5. Now, we expect, because we are taking the square root of a positive value here, then we expect these values A and B to be positive. But also, when someone goes on and uses, for example, this, when you come to this one here, they have also put the condition. So still, you will take the magnitude of that, and it will also give you the same value. Now, what we are saying that when you reach here, you already have your 3, and you expect your A to be a number which is not under the square root, and B to be a number which is not under the square root. So what you can easily do at that given stage, you can simply take your A to be 3. If you take your A to be 3, then it means you will simply substitute and get your B as 1. Then you get your answer here. For someone who uses this negative 3 as the value of A, you will get the value of B as a negative 1. So it means for you will have something like this. You will have something which is that square root of 14 plus 6 square root of 5 will give us square root of this will give us negative 3. That is what you will get, negative 3 minus root 5. But of course, this will be same as a negative of 3 plus root 5. And when you reach here and you put it under the square root, under the magnitude here, then you will also remain with 3 plus root of 5. So that is what we are basically talking about. So those are the different ways of how you are supposed to compute that. Okay. So for this person here, we'll have the negative 3, because you will say your A is your A is, when you take this negative here, negative 3. Your A is negative 3. When you substitute it here, your B will also be negative 1. So you will have the square root of 14 plus 6 root 5 to be negative 3 minus root 5. And that is negative of 3 plus root of 5. So you will have that. But of course, you need to remember that you are given the expression as n divided by the magnitude of the square root of 14 plus 6 root 5. So which will mean you will have n divided by the magnitude of 3 plus root 5, which will remain as n over 3 plus root 5. Then for the person who will take the negative, you will have n over magnitude of negative of 3 plus root 5, which will also be n over 3 plus root 5. Because magnitude of a positive is positive, magnitude of a negative is positive. So you will have the same answer. So that is what we are considering. So the fact that these ones here, the fact that A here is is irrational, that is under the square root, and this is also under the square root. Depending on what we need a number which is not under the square root for A and B. So it is important that you take the values for A to be root 3 and -3. So you discard this. You discard that. So this is what we shall obtain. N over 3 plus root 5, N over 3 plus root 5. Now when we come back to this, so when we come back to this, so you'll be able to obtain N. Now remember, you are given N as 4. So since we have N as 4, then now it means L plus or minus W square root of H will be equal to 4 divided by this. So this one is what we obtained here. This is what we obtained here. So we have gone through all this process. So we are saying with N equaling to 4, it was given here. With N equaling to 4, it was given here, somewhere here. So they are saying the right length L, width W, and H, all measured in meters for the pond for every N in thousands fingerlings are given by this, obtained by dividing the number N by the magnitude of the square root of this. Okay, so that is what we are having. Now from that given point, we are saying since N is 4, then L plus or minus W square root of H is same as 4 over 3 plus the square root of 5. So from here, rationalize. So how do we rationalize? Multiply by the conjugate of that, 3 minus square root of 5 in 3 minus square root of 5. So when you do that, you will have 4 into 3 minus square root of 5 divided, this is the difference of two squares, 3 squared, minus square root of 5, which is squared. So this will be 4 into 3 minus square root of 5 divided by 9 minus 5. So this is 4 into that divided by 9 minus 5, which is 4. So this and this reduces. This reduces by that, and you will have 3 minus square root of 5. So that is what we shall get. So that will be L plus or minus W square root of H. Now, since we are given that, or since we have obtained that length plus or minus W square root of H is same as this, now you need to compare the rational and the irrational parts. So when you compare, then here, since this is a plus or minus, and here we have a minus, so we shall be taking a minus here. So we shall be considering L minus W square root of H to be equal to 3 minus square root of 5. So when you compare the two, your L will be taking this, then your W will be the coefficient of square root of 5, which is 1, and your H will be the one which is under the square root, and that will be 5. So after obtaining the length, width, and the height, then you will go on and obtain the volume. And the volume will be in the form of length times width times the height. And when you do that, you should be able to get your volume as 15 meters cubed. So after getting that, then go on and compare this with the one that you were given. So the constraint was it should not exceed 20 meters cubed. And as we have seen, it is not exceeding. It is actually less than or equal to 20 meters cubed. So after that, you need to give your conclusion. So the conclusion, you have the length, you have got the width and height, giving you the volume as 15 meters cubed. And we shall be saying that since 15 meters cubed does not exceed the available 20 meters cubed of the space, the pond size for 4,000 fingerlings is feasible. So it means the neighbor does not need to reduce the number of fingerlings on the space grounds. So we are making that conclusion basing on this. They are saying he wishes that the size of the pond to start with does not exceed this. We have seen it does not exceed. And if it exceeds this capacity, then he will have to reduce on the fingerlings to fit in the available space. So clearly, he should not reduce on the number of the fingerlings to fit in the available space. So that will be our conclusion. So with that, our first part will be answered, and for that case, we shall now have the next part. Unless there is any question, then we can now look at the next part. Yes, please, Frederick. Frederick, your hand is up. You can try to unmute. Yes, Mbusa.
So thank you.
Okay, please.
And the value of n equal to 4 was got, but the rest I'm okay.
It is here. The right length L, width W, and height H, all measured in meters for the point for every n. N is in thousands.
Yes.
So if it is in the thousands, here they have told you thousand fingerings, okay? Here they have told us that the neighbor plans to start with 4,000. Is starting with 4,000. So if he's starting with 4,000, what will be the value of n? If n is in thousands,
Before.
n will be 4, because it will be 4,000 divided by 1,000, and that will mean n will be 4.
Okay, sir.
All right. James? James, your hand is up.
Excuse me.
Yes, please.
Excuse me, sir.
Yes.
My screen is just displaying TV Math Hub just as an icon.
Hey, that is you. What you do, you can first
leave.
Displaying
the video.
Yes, you can first leave the meeting, then you come back. It might work. I think it might be network. Okay. All right. So that is it all. Let us look at Frederick.
Okay.
Your hand is up.
Yeah, master.
Yes, please.
Hello.
Yes, I'm getting you.
We have got two values of A.
I've got?
We had two values of A.
Yes.
One was root 5 and then 3. I had a question about that, but then I figured it out. Yeah, I've got it.
You have?
I had a question about that, but then I've understood.
Okay.
Having the same value, 3 plus root 5 and then 3 plus root 5.
Yes.
Yeah.
Okay, please. So, Elvis, you have a question?
Yes, sir.
Yes, please.
Thank you, sir. When you are calculating at the end there, I got confused when you are comparing and you neglected the negative.
Where? Here.
At the end, there.
No,
when you are comparing.
I'm comparing. So if to compare, you must make sure that the signs which are there are the same.
Are the same.
Yes. So here it is a minus. This is a minus. So the fact that this is a minus and this is a minus, then that one should not affect. But if we had an incidence like arrow plus w square root of h, and we are comparing this with 3 minus a square root of 5, okay?
Yes.
But for this case, it is not like this because we were given two options. So the two options are to help us to make the comparison better. Okay? So what we are saying is now, let us assume that this one was clearly splitted that it is a plus. Okay?
Yes.
So if it is a plus and what you have obtained is this, then that's when you will now consider this minus here. Because you must also place this as like L plus W square root of H, which is equal to 3 plus negative 1 square root of 5. So you put a plus and a plus here, so you can compare the two. So when you are comparing now, you can say L is 3, then W becomes negative what? Negative 1. Negative 1, isn't it? So there, the negative will make an impact. The negative makes an impact here. But for our case, yes, here it will affect. If it is like this and yet you are comparing it with this, the negative will make an impact. But what we are having here is a minus. This is a minus. Okay? So the fact this is a minus, it will not make an impact.
Yes, sir.
So that is we can do that.
Okay.
Okay, so that is all about this number here. So from there, we can try to look at the next part, and that is the part that will be the second part for our item. So the next part is saying he has also been told that the profits. Okay, hope we are starting. Okay, so he has also been told that the profits P is in millions. Please always look at that. P is in millions. From the business depends on the number N. N is in thousands of fingerlings sold per harvest. He has also been told that these profits equal to the ratio of the fingerlings increased by 2. or divided by the square of the fingerlings less 5 times the fingerlings and increased by 6. He wants to determine the range of fingerlings that will give him at least 1 million shillings per harvest to establish whether his choice of starting with 4,000 fingerlings will be feasible. So this will be our next part. So that is our second part of our scenario. That is the second part of our scenario. He has also been told that the profits P in millions from his business depend on the number N of fingerlings sold per harvest. He has been told that these profits equal to the ratio of the fingerlings increased by 2 or divided by the square of the fingerlings and less 5 times the fingerlings and increased by 6. We shall look at that. So let us first look at the given information. So we are given this, that the profit model is this one here, N plus 2. Let us go back. They are saying he has been told that these profits equal. So the P is equal to the ratio of the fingerlings, that is N, increased by 2. So P is equal to N increased by 2, N plus 2, divided by or divided, the whole of it divided by the square of the fingerlings, divided by the square of the fingerlings, N squared. Okay? Then less 5 times the fingerlings, that is minus 5 times N, again increased by 6, then plus 6. So that is the expression for the profit model. So that is P of N is N plus 2 divided by N squared minus 5N plus 6. But of course, this is in million shillings. That is the P. P is in million shillings. Where is it? P is in million shillings, is here. Next, the N is representing the fingerlings in thousands. We already know that. So what is the requirement? We go on. They are saying he wants to determine the range of fingerlings that will give him at least 1 million shillings per harvest to establish whether his choice of starting with 4,000 fingerlings will be feasible. So the condition is, or the requirement is that the profit should be of at least 1 million shillings per harvest, meaning that P of N should be greater or equal to 1, at least 1 million. So that is 1. Remember, P is already in millions. So that is P of N greater or equal to 1. That is the condition. So since we know P of N, and we are given this one here, we want to see whether the N that he started with, which is 4, will actually be giving us the harvest, which is at least 1 million shillings in profits. So we shall look at the required response. Now, this scenario is basically testing your knowledge about rational inequality. So it requires the factorization of the quadratic denominator. You need to be careful about the sign analysis and also the exclusion of values that make the denominator 0. Then after that, we check whether the planned N equaling to 4 lies within the feasible range. If we do that, then we shall be able to have answered this part. We shall look at the response. So what we are interested in is that P of N should be greater or equal to 1. So if P of N is greater or equal to 1, it means N plus 2 divided by N squared minus 5N plus 6 should be greater or equal to 1. So you can simplify this. When you simplify this by factorization, you should be able to get N minus 2 into N minus 3, which I believe everyone knows how to factorize. Now, from this given point, please, when you reach here, if you're having N plus 2 divided by N squared minus 5N plus 6 greater or equal to 1, don't multiply, don't cross multiply. That is where you will stop earning the marks. The moment you deal with cross multiplication here, everything is done. Now, from this given point, we are first simplifying this to be in terms of N minus 2 and N minus 3. So it means having this, what you need to do is to bring this one on the other side, and this is the step we are talking about. Rearrange such that the one comes this side. So this will be greater or equal to 0. Then from here, get the LCM. This is what we have done. The LCM will be N minus 2 into n minus 3. Divided by this, you get 1, times this, you get n plus 2. Minus this divided by 1, you get this. Multiply it with 1, you will get this. Now, when you expand this one back, you will get back this. N squared minus 5n plus 6. Then affect it with this minus. So you are having minus into n squared. This is minus 5n plus 6. So when you affect this with this minus, then you'll be able to get n squared. Okay, so you are simplifying the whole of it now. So you are having n plus 2 minus, now put the minus there, n squared plus 5n minus 6. So n plus 5n, you'll get 6n. This is negative n squared. 2 minus 6, you'll get negative 4. So what will it give us? It will give us negative n squared plus 6n minus 4 divided by n minus 2 into n minus 3. The whole of it is greater or equal to 0. So from here, you can, what we can do, we can again pull out this minus. We get n squared minus 6n plus 4 divided by n minus 2 into n minus 3. The whole of this is greater or equal to 0. Then divide it through by negative. When you divide it through by this negative, then this inequality sign will change. And this is what you will have. So you remain with this divided by this, but this sign changes. Now, we deal with this. Now, we need to look at, we need to factorize this first. But factorizing this might not be easy, because we cannot easily get the factors which we can add together to get negative 6, multiply together to get 4. So what we can do, we can now apply what we call the quadratic formula. When you apply the quadratic formula, you'll be able to get n as 6 plus or minus square root of 36 minus 16, which will give us 3 plus or minus square root of 5. Because square root of 20 can be simplified to be 4 times 5. And when you simplify this, this will be 2 square root of 5. So when you have 2 square root of 5 here, by 2 is 1, by 2 is 1, by 2 is 3. So you get 3 plus or minus square root of 5. So that is what we shall have. So having obtained that, this implies if you did, you can go on and simplify it. So, but when you are simplifying it, make it to about 4 decimal places. So this should be 3 minus square root of 5, which is 0.7639. So this should be to 4 decimal places, 39. And then if you add the 2, then you should be able to get 5.2361 to 4 decimal places. So maintain the 4 decimal places. So this is what you'll get. Now, we are having n equaling to 3 plus square root of 5, which means I can have this as, when I take this one on the other side, these are your critical points. Remember, these are your critical points. 5.2361. This one here, 0.7639. N is equal to 2. N is equal to 3. So we are getting these critical points from here. So when you simplify this upper one, you'll get this into that. Where is this one coming from? We have n equaling to 3 plus square root of 5, meaning n minus 3 plus root of 5 is equal to 0. Okay, so likewise, if I have n equaling to 3 minus root of 5, I can as well say n minus 3, this one here, 3 minus root of 5. So when I have this, I can have it like this, Or else, if you want, you can maintain these decimal points here. So n is equal to that, n is equal to this. So this is what we shall have. So to get the critical points, equate each of these to 0. So when you equate this n minus 2 to 0, you will get 2. N minus 3 to 0, you get 3. For n minus 3 plus root 5, you will also get this one here. That is 5.2361. When you equate this one here to 0, you will get this one here, 0.7639. So these are your critical points. So you need to make a table to look at the sign change. And the sign change you will be looking at is the sign for this one here. So we have not put it here, but the sign we are basically looking at is the sign for n minus. To simplify it, I will use this so everyone can see that. So the sign we are testing for is for n minus 3 minus root 5 is 0.7639 into n minus this is the one, n minus 5.3 is 2361. Then you are dividing the whole of this by n minus 2 into n minus 3. So now you need to test for the n less than this, less than 0.76. You can put any value. You can put any value. Maybe let me write it here so it is clear to everyone. N minus 0.7639. This is the what we are testing. N minus 5.3. It is actually 2361. Then you are dividing this by n minus 2 into n minus 3. So this is the sign we are testing for. We are testing the sign for this. So for n, remember, you are having this as your critical points. 0.7639, 2, 3, and 5. So you must test for the region less than this, the region between this and this, the region between this and this, the region between this and this, and the region which is greater than this. So those are the regions we are having here. The region less than this, the region between this and this is the region between 2 and 3, the region between 3 and this one here, 5 point that, this is the region, and lastly the region above this. So that is the table that you will have. Now from this, we are testing for the sign. Now put for n equaling, for example, to 0, because it is less than this. So n equaling to 0, this will give us a negative, this will be a negative, this is a negative, negative. Negative times negative, we get a positive. Negative times a negative, we get a positive. So positive divided by positive, we shall have positive. A region between these two, you can put like 1, n equaling to 1. So if n is equal to 1, this will be positive. This will be a minus. So up here we are getting it, a positive and a minus, which is a minus. This will be a minus, this will be a minus, so which will give us a positive. So negative divided by positive is a negative. So you do the same for the remaining ones. So you will have a plus, a minus here, a plus, a minus there, a plus. Now after getting that, then we need the region. These are the regions we are having, but we need the region where the whole of this is less or equal to 0. This is what we are looking at, less or equal to 0. So the region which is less or equal to 0, for this expression to be equal to 0, the first thing is it should not be equal to 2. First of all, if it is equal to 2 or if it is equal to 3, it will be undefined. So it means n equaling to 2, it means n should not be equal to 2 or n should not be equal to 3. This will be undefined, because if it is equal to 2, this will be 0. Any number divided by 0, it will be undefined. So it means for this to hold, first of all, n should not be 2, n should not be 3. But for us to get a 0, then n should be equal to 3 plus square root of 5, or n should be equal to this. N should be equal to this. For us to get a 0 here, then n can be equal to 0.7639, or n can be equal to this. N should be equal to 3 plus root 5, which is 5.2361. So n can be equal to that. This is for this inequality to give us 0. That is 1. Then 2, for it to be less than 0, it should be negative. So this qualifies and this qualifies. So these are the feasible regions. Now we shall go back and look at this one here. They are saying he wants to determine the range of fingerlings that will give him at least 1 then per harvest. Then establish whether his choice of starting with 4,000 fingerlings will be feasible. So we need to look at where n is equal to 4. So where do we have n equaling to 4? N is equal to 4. It is not in this region, it is not in this, it is not in that. But it is between 3 and 5.236. So 4 is here. So our feasible regions, we have seen, this is the region, this one here, and this region here, this one here. These are the regions. And we saw that for this one here, to be equal to 0, then it should be equal to this. So that's why we have less or equal here. And it should be equal to this. That's why we have less or equal to here. So these are the two feasible regions. And we need to establish where n is equal to 4. N is equal to 4 is in this region. This region, we have already seen that region, this is the region here. This region here is actually a feasible region. So we can easily see that n equaling to 4 lies within the feasible region. So if that is the case, then we can give our conclusion that since n equaling to 4 lies in the interval, this interval here, which is the feasible interval, then starting with 4,000 fingerlings will give a profit of at least this amount harvest. So this choice is feasible profitability grounds. So we shall conclude that starting with n equaling to 4 will be feasible. Remember, we are using n equaling to 4 because n is in thousands. N is in thousands. So since n lies within this region, and we have already seen that this region here is a region which is satisfying the given inequality, then it means we can generally give this conclusion. And that will be the required response per that part there. Unless there are questions, then we can look at the next part, which is the last part for that item. Members is still following. Members, I'm not seeing any reactions. Are we okay? Okay, please. Yes, James?
I was confused on the way you decided on those intervals.
How we got these intervals?
Where you decided? Yes.
Where?
From that table.
This one. Where is the problem? How we got this?
I didn't understand you well when.
Okay. How
when we are deciding.
So this is how we make the table of critical values. If you have your critical points now, the challenge is we are having these decimal points. Maybe it is what is confusing you. Let us look at the case where you are having your table. You have, for example, n minus 2 into n minus 5. Okay, let me use 3 here. Okay, 4. Let me use 4. Over, you have like n minus 2 into n minus 3. So you have the whole of this greater or equal to 0. So how do you get a table? You first get your critical points. Okay? So get the critical points by equating each of these to 0. So when I equate each of them to 0, I get 4. I get this one when I equate it to 0, 5. When I equate this to 0. You can even have the positive. It is not a mass that everything should be minus. So maybe we can put a negative also. Okay? So when I equate this to 0, I get negative 4, isn't it? When I equate this to 0, I get 5. When I equate this to 0, I get 2.
Yes.
When I equate this to 0, I get 3. So what you do is rearrange them, starting with the smallest, negative 4, 2, 3, and 5. Isn't it?
Yes.
Now, after arranging them like this, you will be testing regions like this. You will start with the region which is less than this. That is n less than negative 4. You will test the region between this and this. That is negative 4. Less n, less 2. You will test for the region between this and this. That is 2. Less n, less 3. You will test for the region between this and this. That is 3. Less n, less 5. And lastly, you will test for the region above that. So that is how you obtain the table of critical points. Then you will have this one here, your n plus 4 into n minus 5 over n minus 2 into n minus 2. Then test for the sign of this one by putting any value in this given. Is that one okay? So this is what we did here. We obtained the critical points. This was the critical point. This,
but
this,
in some.
Where is the next conclusion now?
In some textbooks, they usually use greater or equal, less or equal.
Oh, no. There is nowhere you have seen greater or equal in mind.
In some textbooks.
Greater or equal? In this one here? When you are testing the regions?
Yeah,
the greater or equal comes at the end. It comes at the end. Like the
maybe if I don't remember very well.
Like the way we have introduced the greater or equal here. You know the reason why? Because we are looking at because our expression should be less or equal to what? Should be less or equal to 0, isn't it? So we want to know when do we get a 0?
Less or equal to 0.
Yes, should be less or equal to 0. So because here we use less than, so first of all, it means the one for less than is already there. This region is already giving us a minus. This region is already giving us a minus. So for less, it is okay. But how do you get a 0? You get a 0 when n, because you have like this as n minus 0.7639. So under which condition will you get this one 0? Is when n is equal to this. is when n, when I equate this to 0. So it is when n is equal to 0.7689. And it is also when n is equal to 5.2361. So we look for where we have that. We look at where we have this. So where do we have this? This is the 0.7689. So that's why we are putting less or equal here, but we are not putting it here. Then for this one here, when n is equal to 5 point, this is the expression. Okay? So we are putting less or equal as well here. The reason is it is only when n is equal to this that it will give us 0. It is only when n is equal to this that it will give us 0. So you have to be careful to when you are using less or equal. Less or equal should come at the end, especially for the expressions where you have greater or equal, less or equal. But don't place them here. Otherwise, will you say that 2 less or equal to n less or equal to 3 less or equal to that? The equal comes as a condition. When do you get that equaling to 0? Because now right here, when you put n equaling to 2, that will be wrong. Because the moment n is equal to 2, the whole of this will be undefined. So you cannot put equals less or equal here. Hope that is okay. All right. So let us look at the next part. Let us look at the next part. That is the last part for this. So they are saying he has also been told that the cost in hundreds of thousands, for farming any in thousands fingerlings is given by dividing the number of fingerlings with the magnitude of the principal argument of the complex number z, which is here. So he wishes that the cost does not exceed his planned budget of 300,000. If it exceeds, he will reduce on the fingerlings. So this will be like our third part, and that will be the last part for that scenario. So we can go through that very fast. So we are looking at the cost. Before we look at that, let us start with the given information. So the cost model is that the cost, which is in hundreds of thousands, will be same as, let us read that one again. The cost, you has been told that the cost, which is in hundreds of thousands, for farming n, which is in thousands, is obtained by dividing the number of fingerlings. You are dividing the number of fingerlings, you are getting n, you are getting this n, you are dividing it by the magnitude of the principal argument of the complex number. So you are dividing it by the argument of the magnitude of the argument, where the z is given. And we already know that. So the argument is the magnitude of the principal angle. This one here, argument in this one here is the magnitude of the principal argument of z. And that will be in radians, of course. But we are given the budget constraint that the cost should not exceed 300 Ugandan shillings. And that is actually 3 in the given 100,000 units. Actually, it should not exceed 3 because we are also given that the cost is in hundreds of thousands. So let us look at that one there. So let us look at the required response. So from which topic is part 2 and part 3? Part 2 and part 3 are from algebra. So algebra is the construct. It has got very many topics. Complex numbers, binomial theorem, very many numbers. So quadratic equations, all those ones there. Inequalities, they are in algebra. So we already talked about the topics which make up algebra. So in case that one is still a problem, I will refer you now to my video on YouTube. I already talked about that, all the topics in those different constructs. So we are saying the cost feasibility is what we are interested in by using the argument of the complex number. So this scenario will be testing your knowledge of complex number arithmetic. That is, if you know how to deal with multiplication, if you know how to deal with the division of complex numbers, and the principal argument of a complex number. So this is what we shall be doing. We shall simplify z to Cartesian form, which is in the form of x plus iy. Then after we find the argument of z, then that should be obtained by using the correct quadrant. And again, after we take its magnitude. Then after doing that, use it to evaluate the cost at n equaling to 4 against the given budget. So that is what we shall be talking about. Now, you must recall how to multiply. You must recall how to multiply. So we want to simplify this. So I'm first dealing with 2 minus I into 5 plus 12I. Then I also simplify 1 plus 2I squared. Then I divide the 2. So that is what we are dealing with. We deal with the numerator first. We simplify this. 2 times 5, 10. 2 times 12I, 24I. Negative I times 5, negative 5I. Negative I times 12I, negative 12I squared. So this is 10. This one here is 19I. Negative 12I squared is same as negative 12 times negative 1, which is positive 12. And this will be simplified, and it will give us 22 plus 19I. Then also simplify the denominator by expanding this. So by expansion, that is 1 squared plus 2 times 1 times 2I, which is 4I, then plus 2I squared, which is 4I squared. Simplify that, get negative 3 plus 4I. So in other words, we have the numerator as that, we have the denominator as that. So this is our Z again. So now this is a simplified expression for Z, but as again, you realize that we still have the I in the denominator. So we again need to simplify this further. So you need to recall that to divide complex numbers, you multiply the numerator and the denominator by the conjugate of the denominator. So rationalize this by multiplying by the conjugate of the denominator. So when you do that, this is what we shall have. So multiply by the conjugate of the denominator. The conjugate of the denominator is obtained by simply changing the sign for the imaginary. So if it is a plus, then the conjugate becomes minus 3 minus 4I. You change the sign of the imaginary part. So when you change the sign of the imaginary part, if it is a positive, it becomes a minus. This is what we shall have. And this is what we shall multiply both in the numerator and the denominator. Now from there, simplify the denominator. This is a difference of 2 squares. So everyone should be able to do that. That is negative 3 squared minus 4I, which is squared, which will give us 9 minus 16I squared. And this is 9 minus 16, which will give us 25. And that is the 25. Simplify the numerator by multiplying. So 22 times negative 3, negative 36. Times this, negative 88I. 19 times negative 3, negative 57I. 19 times 19I times negative 4I. That is negative 76I squared. Simplify, and you should be able to get 10 minus 145I. So what does that imply? That implies that your Z, which is 10 minus 145I divided by 25, can be simplified. So you can have this as 10 over 25 minus 145 over 25I. So that is what we shall have. So you can put by 5. You put by 5, this will be 2 divided by 5. And by 5 here, it will give us, what is 145 divided by 5? That will be 29. Okay, so that will be 29 divided by 5I. So this is what you will have. You can have it as 0.4 minus 5.8I. Now, after getting that, you need, this is your Z. So your Z is 2 over 5 minus 29 over 5I. So go back to your quadrants, rotate where this one could be. So when you rotate this one here, this is, remember, the imaginary, this is the real part. Now, rotate this, the real part is positive, so it means it will be along this positive real axis, that is 2 over 5. This is a minus, so it will be this side. This is 29 over 5. So it means your angle should be within this quadrant. So this is where you will have your theta. So it will be in this quadrant. And you need to remember that the angle, your argument should not exceed 180 degrees. So if it exceeds, then that one becomes wrong. So it should be either in this quadrant. And in case it is in this quadrant, you take the negative direction, not the positive direction. So this is where our angle will be. So this is what we are having. This is what we are having. So you will get that. Okay, so this will be 29 divided by 5. This will be our 2 divided by 5. Now, from there, you need to get this angle theta. So your angle theta will be tan inverse of the opposite is 29/5 divided by 2/5, which is same as tan inverse of 14.5. So when you get this angle, it will be giving you, it will be 86.05. This is the angle you get. However, after getting this angle, then your argument should be this angle here. Remember, you have gotten this angle, but the argument is the angle which you measure from this axis here. So it means you will be measuring that angle, taking that direction, and that's why we are saying that this angle that we are getting here, after getting this, we are again saying that our argument will actually be 86.05 degrees. And this is the argument of Z. And this in radians is same as getting 86.05 divided by 180 pi. Or else you can get this one directly in radians by taking that. Okay, so when you take that 86.05, you divide it by 180, multiply by pi, you should be able to get 1.5019 radians. So we are saying our argument is this, but this angle is a minus, please. Don't forget that. The argument is a minus simply because we are taking this direction. Remember, we measure angles, negative angles, by taking the clockwise direction. So this value will be a negative. So that is negative 1.5019 radians. So that will be the argument of Z. Now, after getting that, what do we need? We need the cost. We need the cost. Remember, here we had that. This is what we need. We need the cost, which is in hundreds of thousand, and that is n divided by the magnitude of argument of Z. Magnitude of this. So we have n as 4. We have got the arg of Z. So we shall now take the magnitude of that and obtain the cost. Okay, so let us get the cost now. So what will be the cost? The cost is n divided by the magnitude of arg of Z. So that will be same as 4. N is 4 divided by the magnitude of this. So you are taking magnitude of negative 1.5019. Magnitude of this, it becomes 1.5019. So this is the one we are having. And this will give you that value. So when you get 4 divided by that answer, you should be able to get 2.633. So 33 like that. So, and this value here, the cost you are getting is in hundreds of thousands. So it means the total cost now will be this value times 100,000, which will give us this answer. So looking at this, compare it with the given budget, which is of 300,000, and now you realize that value is actually less than the given constraint of the budget. So we give the conclusion. So we have got the cost, which is approximately equal to that, and we are saying that since the cost of this one here is within the budget, then starting with 4,000 fingerlings is also feasible on cost grounds, and no reduction in fingerlings is needed. And that will be the required answer. So with that, it means we shall also have that one done. However, you can also do this in a different approach by using the column method, that is modulus argument. You can get the argument of Z1, Z2 over Z3 squared by using the fact that arg Z1 plus arg Z2 minus 2 arg Z3 will also be in position to give you the required answer as well. So that is at the end of this item here. And there are some few questions here which we should take and believe that. Yes, Atim? Florence, Atim, I see your hand is up. Elvis?
Sir, when we were learning trigonometry, we were told that pi means 180. Is it true?
Yes, pi radians is equal to 180 degrees.
180. When I'm multiplying easily on our answer, I'm getting a different answer.
What are you doing? From here?
Yes, from there. Negative 86.05 divided by 100 times 180. I'm getting that negative 86.05.
No, again, no, we are converting from degrees to radians. And we are saying that 180 degrees is equal to pi radians, isn't
Yes.
it? So what
Yes.
about 1 degree? 1 degree will be equal to pi divided by 180 radians. Is it okay?
Yes.
Then what
Yes.
about negative 86.05 degrees?
Yeah.
It will be negative 86.05 degrees times, because if 1 degree is same as pi over 180, then what about this? It will be same as this times pi over 180. Okay?
Yeah, I've got it.
Then
Yes.
this will be now in radians. So what you are doing
Yeah.
is you are actually not converting, because you are saying this divided by 180 again times 180. So you are again leaving it in degrees instead.
Yes.
So that is
Thank you, sir.
okay. So that marks the end of our item 2, and possibly I want us to look at these ones very fast. There are some who tried this item here. Let me check. There are some who tried that item, and we can check through and see if what they did is okay. Okay, so this person got the value directly from the calculator. So the person simply got 4 divided by this and placed on the calculator, got a V. So that one is wrong. So this is not right, isn't it? From what we have seen, that should not be right. So don't simply get this directly from the calculator and you get the answer. So they were supposed to get the length, the width, and the height. Then after, they multiply to get the volume. Okay, so this one here, I think the process is okay. However, has it become this? When you simplify this, surely it is not right. When you simplify this, you will not get this. Okay, so that is where the challenge is. That is where the challenge is, because when you simplify this, one here, let's see. When you simplify, n minus that. So when you simplify 3 minus root 5, you will not get that answer. So that one will be wrong. So this will not be right. This one here. So, and from where did he get this? So you must avoid some of these mistakes, because where did he get this? So you should be able to show that, because from nowhere you cannot easily get this from the head. You cannot. So that becomes also a problem, but the way he had put it was okay. I also expected him to have the other mistake. Oh, the problem is here. How can you be having n plus 2 divided by n squared minus 5n plus 6? And you say this is same as n plus 2 over n squared minus 5n plus 6? So those are two different things. Those are two different things. So that one makes it wrong. So it makes the whole of it to be wrong now. So the whole of it will be wrong. The argument, I want to check. Okay, that one was okay. Okay, that is okay. This one is getting the argument as a positive value. The argument should be negative value, should have maintained that negative. And from here, he converts that to radians. We give the argument in terms of radians. So that is what should have been done. Okay. That is what should have been done there. Okay, so that is what he did. So I hope you have seen some of the challenges, some of the problems. People are simply placing this on the calculator and getting the values, not showing the clear messages. You have n plus 2 divided by n squared minus 5n plus 6. You add the 6, and yet the 6 is in the denominator. Using the calculator here to simply get the answer. So you get the answer directly from the calculator without showing the proper messages. Okay, so you need to avoid some of those small mistakes there. Let us check through this one here. What this one did. Okay. So did this one try that? This one didn't try. Can't see that number there. Okay, it is here. Hey, it is not clear. It is in the diagonal. Okay, so this is not a bit clear. What I wanted is this. I think this is okay now. This is okay. You bring this one, try to simplify, show the process of getting these values, get the critical points, simplify. Hey, so stopped here. So this should be continuing. So no continuation there. Okay. Okay. So this one tried it and got 3 minus root 5. 3 plus root 5, simplified that. Okay. So this was okay. So that one got it right. So this one here, so this one here failed to simplify. This one failed to simplify. Actually failed to simplify this. So that brought him problems there. Okay. So this one also was wrong. So he got a wrong value here. So of course, everything here becomes wrong as well. Okay, let us go through the next item. Let us go through the next item. So I hope members are still around. Members, are we okay? Are we good to go? Elvis, you still have a question? Or you are seconding us to go? Okay, okay. Okay, so let us look at the next. Let us look at the next item. And the next item will be item number 3. So I hope we shall finish that one in a few minutes. Actually, in 1 hour remaining, because we are here up to 6. So let's do whatever it takes to finish this on time. So this is item number 3. Okay. So this is item number 3. Now we shall go through this item very fast, so we can finish it within the remaining 1 hour. So it says, an old woman rearing cows and goats wants to start rearing a new breed of sheep to supply her. An old woman rearing cows and goats wants to start rearing a new breed of sheep to supply her with wool. Due to old age, she had lost the track of the market prices of these 3 animals. She recalls that on some day she sold a cow and 3 goats to the market, and she bought one of this new breed of sheep, and she had 2.4 million resulting from this transaction. On another day, she sold 3 cows and 1 goat, and also bought one of these sheep, and had 4.4 left. This transaction. She also noted that on the day she bought 3 of these this breed of sheep, she had sold a cow and a goat on the same day, and she was left with 200,000 shillings from this transaction. She wants now to buy 5 sheep at once. She wishes to get the money from the sale of 2 goats and 2 cows and remain with a balance of not less than 1 million for her needs. And if she cannot have this balance, then she will be forced to sell another goat to achieve her plan. The old woman wants to also construct a shelter for the sheep. Her veterinarian, word is very complicated. Her vet has advised her that the number N of sheep per shelter depends on length and width of the shelter to be constructed. The vet told her that the number of sheep per shelter permutation, the width of the shelter must be equal to 30 times the number of sheep per shelter combination the length of the shelter. The already wants the length of the shelter to be 5 meters and the width to be 4 meters. Now, she wishes that the number of sheep per shelter exceeds 7 for her to implement the plan, or else she waits for some time. Next, we are told, the vet told her that this breed of sheep multiplied geometrically at a common ratio of 2 sheep per year. Then the old lady was impressed and thought of how many sheep she would be having after 5 years, having started off with only 10 sheep. She wished that if in 5 years the number of sheep on her farm exceeded 300 sheep, then she will give up rearing goats and concentrate on cows and sheep only. Okay. Next, she has also been told that the price of sheep in the next 5 years will be 3 times the sum of the modulus of the square roots of the complex number 1 plus I square root of 3 in hundreds of thousands. She wants to know what this price will be, and if it exceeds 800,000, then she can take a loan now. And this is the task. Help the old woman make informed decisions. So that is what we are given, and we shall look at the required response. We shall begin by looking at the given information. Then from the given information, we can look at how we can go through that and get the required response. So the given information is that for the first part that we need to look at, answer this scenario, we need to again look at this in different parts. So the first one is that an old woman is rearing cows and goats and wants to start rearing a new breed of sheep to supply her wool. Due to old age, she had lost track of the market prices of these 3 animals, but she recalls that one day she sold a cow and 3 goats to the market, and she bought one of this new breed of sheep, and she had 2.4 million resulting from this transaction. On another day, she sold 3 cows and 1 goat, and also bought one of these sheep, and she had 4.4 million left from this transaction. She also noted that on the day she bought 3 of this breed, she had sold a cow and a goat on the same day, and she was left with only this amount. She wants to buy 5 sheep at once. Now she wishes to get this money from the sale of 2 cows and 2 goats and remain with a balance of not less than 1 million for her needs. And if she cannot have this balance, then she will be forced to sell another goat to achieve her plan. So this will be our first part of our scenario, and that is what we shall be looking at first. Okay. Now, the given information is we are dealing with the cost of a cow, a goat, and a sheep. So what we can do, we shall first rate the price of a cow to be C, price of a goat to be G, price of a sheep to be S. All of these are in millions of shillings. Let us look at the first day. The first day is here. The first day, she records that on some day, she had 2.5 million left. That was after selling a cow and 3 goats on the market, and she had bought one of this new breed. So she had sold a cow at a cost which we are calling C, plus 3 goats, but she bought, using this money, she bought a sheep which was at cost S, and this is the money she was left with, and that is 2.4. So this is what we are saying. She sold 1 cow and 3 goats, but bought 1 sheep using that money, and she was left with 2.4 million. Meaning that when you get the amount she sold the cow plus the amount she got after selling 3 goats, that amount, when you remove the amount she used to buy the sheep, she was left with 2.4 millions. So we are saying the cost of the cow, the goat, and the sheep are all in million shillings. So that is what we shall have. And this will be our equation number 1. Day 2. On day 2, This is what happens. On day 2, another day, she sold the 3 cows and 1 goat. 3 cows and 1 goat. So this is the total amount she got from 3 cows and 1 goat. And she bought, okay, and bought 1 of these sheep, and she was remaining with 4.4. 4.4. So this is what we are having. Next day she sold 3 cows, 1 goat, bought 1 sheep. So that means that the cost will be 3C plus G minus S is equal to 4.4. Equation number 2. Next, day 3. Day 3, we are told, next day, okay, let us see. She also noted that the day she bought 3 of these sheep, now she bought 3 of these sheep. Now, after buying 3 of them, let us see, she had sold a cow and a goat on the same day, and she was left with only 200,000. So she had sold a cow and a goat and used some of this money to buy 3 sheep, but the total amount remaining was 200. But since we are dealing with millions, this is 200 divided by a million, that is 0.2. That will be the amount. So C plus G minus 3S will be 0.2. This is equation number 3. So what is the plan? The plan is to buy 5 sheep. And how will she buy the 5 sheep? By selling 2 cows and 2 goats. And she wants that the balance is greater or equal to 1 million shillings. That is what we are told. Okay? She now wants to buy 5 sheep at once. She wishes that 1 million, she wishes to get, okay, to get this money from the sale of 2 cows and 2 goats and remain with a balance of not less than 1 million. So the balance should actually be greater or equal to 1 million. So this is the information that we can extract that will help us to answer the first part. Now let us answer that part with that information. So let us look at first prices of cow, goat, sheep, and see whether it will be feasible to buy the 5 sheep. So what will this scenario be testing? This is testing your knowledge of solving 3 linear equations in 3 unknowns, and that is obtained from the transaction descriptions, and that is followed by using the prices that we have obtained to test the real world financial condition, because we need to test whether the balance from the 2 cows and 2 goats after buying 5 sheep will meet the required minimum. Can we go through that? Now, we are having the 3 equations. We are having the 3 equations, and we need to solve these 3 equations to get the values of C, G, and S. I believe everyone at the moment knows how to solve these equations, because I will not go through the process. Is that one okay to everyone? We can do that. Okay. So I believe everyone is able to solve the 3 equations. So if that is the case, let us now look at the values. But the process is here. You can take the screenshot and go through that and see if you are getting the same thing. Now, let us look at the values. So the values that I obtained here, I have a C as 1.5. That is the cost for the cow. Remember, the cost is in millions. This is G, which is 0.5, and S is 0.6. So when you solve that, you should be able to get 1.5, you should be able to get 0.6, you should be able to get 0.5. So if you get that, then we need to look at the feasibility of buying 5 sheep by selling 2 cows and 2 goats. Now we need to know what is the cost of buying the 5 sheep. So that is same as 5 times S, and S is 0.6 millions. So that will give us 3 millions. So someone is asking, is it advisable to put the equations on the calculator and get the answer? No, please. You are supposed to solve that. We have also not put it on the calculator. The procedures are there. So we have also followed the procedures. So we are using the elimination method, and you can use any elimination substitution. So we are getting 2 minus equation 1, and after we substitute it into equation 1, and also substitute it into equation number 3 and get the value. So please don't simply place it on the calculator and you get the answer. So I hope you are able to solve that using appropriate methods of getting those values. So we are looking at the cost of buying the 5 sheep, and it is 3 millions. Then what will be the money that she will obtain from selling 2 cows and 2 goats? So selling 2 cows and 2 goats will give us 4 millions. So it means if she sells this and she gets 4 millions and she buys 5 sheep, which is 3 millions, so it means she will be having a balance of 1 million. So this balance of 1 million, it means we can now weigh it together with the given condition, which was she wishes that her money should not be less than 1 million for her needs. And if she cannot have it, then she will be forced to sell another goat to achieve her plan. We can see that the balance that we have obtained is actually equal to 1 million. And what we needed is that the money should not be less or should not be less than 1 million. So since it is 1 million, we shall say that since the balance is of 1 million shillings and is not less than the required 1 million, then it means the old woman can proceed with selling the 2 cows and 2 goats to buy the 5 sheep. In other words, she does not need to sell an extra goat. She does not need to sell an extra goat. And that will be the required response to that part. With that answered, then we can look at the next part. I hope that one is clear. Is everyone okay with that part? So we can go to the next part. Okay. So with that clear, we shall now look at the next part. And the next part is the old woman wants also to construct a shelter for the sheep. Her veterinarian, that is, her vet, has advised that the number n of sheep per shelter depends on the length and the width of the shelter to be constructed. The vet told her that the number of sheep per shelter permutation, the width of the shelter must be equal to 30 times the number of sheep per shelter combination the length of the shelter. The old lady wants the length of the shelter to be 5 meters and the width to be 4 meters. She wishes that the number of sheep per shelter exceeds 7 for her to implement the plan, or else she waits for some other time. This is our second part. Now, with that, we can look at the required response. First of all, we shall talk about the information that we can extract out from that given information. So we are told that we are having the shelter condition. Now, any permutation for what is n? N is the number of sheep per shelter. So we are told here that the number of sheep, the vet told us that the number of sheep per shelter, that is n, permutation the width should be equal to 30 times the number of sheep per shelter combination, this one here, length L. But we are told that the old lady wants the length to be 5. So L is equal to 5 and W is equal to 4. So in other words, any permutation 4 should be equal to 30 any combination 5. So that is what we are having here. So we are saying that the shelter condition is n permutation 4 is equal to 30 n combination 5, where the width is representing 4 meters, and it corresponds to the permutation index, and the length is the 5 meters, which is corresponding to the combination index. And n, as we have said, is representing the number of sheep per shelter. So what is the requirement? The requirement is that the lady wishes that the number of sheep per shelter, which is n, exceeds 7. So that is the requirement. So we need that n should be greater than 7 to implement the plan. We can look at the response to that fully. So what we have seen is the information that we have so far. So looking at this scenario is testing your knowledge of permutation and combinations. and specifically forming and solving an equation relating permutations and combinations using their factorial definitions, and then you compare the result, that is the value of n, against the stated threshold to make a decision. You must be recalling some of these expressions. N permutation r is same as n factorial over n minus r factorial. N combination r is same as n factorial over r factorial into n minus r factorial. You must be recalling some of these. So what we have is n permutation 4 is equal to 30 times n combination 4. By definition of permutation, we shall have n factorial over n minus 4 factorial, which is equal to 30 times n factorial over 5 factorial n minus 5 factorial. Okay. You must get 5 factorial. You can easily get this. 5 factorial is 120, but this can be obtained by getting 5 times 4 times 3 times 2 up to 1. But also you can get this directly from the calculator. There is no limitation there. So 5 factorial is 120. So when you substitute it where there is 5 factorial, then you should have 30 times n factorial over 120 into n minus 5 factorial. But when you simplify this, by 30 is 1, by 30 is 4. So we shall finally remain with n factorial over n minus 4 factorial, which is equal to n factorial over 4 into n minus 4 factorial. Then from here, you realize that n factorial is common. This and this can cancel out. You remain with this. So it can cancel out basically because n factorial cannot be equal to 0. So you can divide it through. When you divide it through, you shall get this. So from here, cross multiply. When you cross multiply, you will have 4 into n minus 5 factorial is equal to n minus 4 factorial. But n minus 4 factorial is same as n minus 4 into n minus 5 factorial. Simply because if you are looking at 5 factorial, so it keeps on reducing. It is 5 times 5 minus 1, which is 4. Now you can say 5 times 4 factorial. Or you can write this as 5 times 4 times 3 factorial, so long as you have not gone up to the value 1. So if I have n minus 4 factorial, then I can write this as n minus 4 into n minus 5 factorial, because n minus 4 minus 1 will give us this. And we cannot simplify this one. We cannot say, or we cannot deal with n minus 5 factorial, simply because when you expand this to n minus 5 factorial, n minus 5 into n minus 6. And our interest is to make sure that we eliminate these factorials. So that's why we are dealing with n minus 4 factorial, because we can easily obtain n minus 5 if we have n minus 4. So I hope that one is okay. So from here, now where there is n minus 4 factorial, we can substitute this. So we shall have 4 into n minus 5 factorial, which is equal to n minus 4 into n minus 5 factorial. So the n minus 5 factorial will cancel out. You remain with 4, which is equal to n minus 4. So our n will be equal to 8. And that will be the value of n. So there is a hand from who? James?
Yes, teacher. I'm confused on the way you have expanded the expression there above.
Which one?
That one where we have n factorial divided by n minus 4 factorial.
This one?
Yes.
How I expanded it? I expanded it.
I'm confused.
I didn't expand this. I dealt with this. This is still okay. It still is there. Is here. What I had is 30 times n factorial over 5 factorial into n minus 5 factorial. So this 5 factorial, I substituted it with 120. Then 30 reduced this to give me n factorial over 4 into n minus 5 factorial, which we did from here. Is it still confusing?
Yeah. I've got you there now.
Okay. So we have, I think.
Thanks.
Okay, please. Elvis, is your hand up or it is up by mistake? Yes, Calvin.
For me, my question is, here on the last part where we are having 4 into n minus 5 equaling to n minus 4, n minus 5 factorial. I'm not understanding that concept there.
How we got this?
Yes, that one.
How we got this?
Yes.
Now, this is here. Now, this is... Now, when you have 5 factorial, you can have 5 factorial as 5 times 4 factorial. That is why I brought this concept. Now, if you are having, if you are having 5 factorial, you can say this is same as 5 times 4 times 3 times 2 times 1.
2 times 1.
If I don't want to write the whole of this, I can say this is 5 times 4 factorial.
Yes.
Now, do you see that we keep on decreasing by 1?
Yes.
Now, if I have n minus 4 factorial, it will be n minus 4 into, now subtract 1 on this. The same way we had this one here, because this is 5, and the next value is 4, the next value is 3. So instead of writing this, you can simply write 4 factorial. If I have n minus 4, what is n minus 4 minus 1?
It is n minus 5.
This is n minus 5. So it means this is n minus 4 into n minus 5 factorial.
Oh.
The same way you had this 5 times 4 factorial, you can also have this as n minus 4 into n minus 5, the whole factorial.
Okay, thank you, sir.
All right, please, welcome. Now, from here, we shall be able to get n as 8. Then after getting n as 8, remember, we need to compare this with the condition. We are given the condition that she wishes that the number of sheep per shelter exceeds 7. So it means when we compare the two, the n we have got and the n that we are given. So the n is 8 and 8 is greater than 7. That implies that n is equal to 8 sheep per shelter. And since 8 is greater than 7, then the number of sheep per shelter exceeds the required minimum. So the old woman can go ahead and implement the shelter plan immediately. So that will be at the conclusion. So let us look at the next part. It says the vet told her that this breed of sheep multiplied geometrically at a common ratio of 2 sheep per year. The old lady was impressed and thought of how many sheep she will be having after 5 years, having started off with only 10 sheep. Then she wished that if in 5 years the number of sheep on her farm exceeded 300 sheep, then she will give up rearing goats and concentrate on cows and sheep only. So looking at this, we are told that the vet told her that this breed of sheep multiplied geometrically at a common ratio. So we have the common ratio of 2, and this is per year. Then the old lady was impressed and thought of how many sheep she will be having after 5 years. How many sheep she will be having after 5 years. So the question asks for the number of sheep she will have after 5 years. We need to note that here they are not asking for the total number of sheep over the 5-year period. So therefore, what we require is the population at that particular time. And of course, since we are dealing with geometric progression, then it means we need the population at that particular time, which is obtained from the GP term formula. So when we are to look at the required response, so we shall be saying that the sheep population after 5 years is what we are interested in. Let us begin by looking at the given information. We are told that the sheep multiply geometrically, that is in a geometric progression. So the common ratio is 2. Then the initial number of sheep is 10. Then the time period under consideration, we are considering 5 years. So what is the decision threshold? If the number of sheep after 5 years exceeds 300, the lady will stop rearing goats and concentrate on only cows and sheep. So that is what we are told. Now, let us try to interpret this scenario. So this situation forms a geometric sequence because the population multiplies by the same constant factor, and that is the common ratio of 2 every year. So what we shall do is we shall take the starting number of the sheep as the first term of the sequence. So the term 1, the first term, is 10 sheep. And that is at the beginning, meaning that is before a year. So that is year 0. So that is at the start of year 1. So what does that one mean? It means T2 will be, the next term will be the term after 1 year. Then term 3 will be the term after 2 years. And that one continues. Then you realize that term 4 will be after 3 years. The 5th term will be after 4 years. And the 6th year term is the term which will be after the 5 years. So that implies that the total number of terms we shall be considering here for the 5 years, then there will be 6 terms of the sequence. Because the first term represents the beginning, which is the year 0, that is before a year, or at the start of year 1. So if the woman starts with 10 sheep, that is the initial, that is year 0 before the end of the first year. So that is why we are having this one here. So in other words, if you are having your year here, so when it is year 0, that is before, that is at the beginning of the first year, it means the term, here the term will be the first term, and here that term is the A we are taking to be the 10. Then after 1 year, we shall have the second term. After the second year, we shall have the third term. After the third year, we shall have the fourth term. After the fourth year, we shall have the 5th term. Then after the 5th year, we shall have the 6th year term. So it means the number of terms under consideration, they are 6. So you have to be careful there, especially if you are to use the term of a geometric progression. So looking at that, therefore, to find the number of sheep after 5 years, we need the 6 year term of the geometric progression. So you must recall that the general formula for the nth term of a GP is T of n, which is equal to A r to the power n minus 1, where A is representing the first term, R represents the common ratio, and n represents the number, that is the term number. So in our case, we want to find the 6 year term, that is when n is equal to 6. So the 6 year term will be same as A r to the power 6 minus 1, which is 10 times 2 to the power 5, and that will give us the value, which is 320. So what does that mean? That means that after 5 years, the farm will have 320 sheep. Now, since 320, of course, is greater than 300, then it means the lady will give up rearing goats and concentrate on only cows and sheep. So that is the solution or the response to that item. But someone can as well interpret this in a different way. Someone can also interpret this in a different way, because we are told that the first term is 10. There is a common ratio of 2. So what will be the population after 5 years? So if initially the person started with A naught, so you can put it in terms of n or in terms of A. So I'm saying if initially the person started with n, that is A naught. So what will be the number A of n after 1 year? So remember, these increase by what? They increase by a ratio of 2. So it means in the first year, initially had A naught as 10. So it means after the first year, that is A1 will be same as like 10 times 2. That is after the first year. After the second year, A2 will be 10 times this value here, 10 times 2, this value here multiplied by 2. So which it can be same as 10 to the power 10 times 2 to the power of 2. Then this is initially, this is after the first year, this is after the second year. Then after the third year, it means A3 will be like this value we have obtained here times 2 again. That is 10 times 2 to the power 2, then multiplied by 2, which is same as 10 times 2 to the power of 3. So in general, A of n is same as 10 times 2 to the power of n. That is what we can have. So in other words, you can say A of n, or what we are calling n of t, will be same as A r to power t, ar to the power of t. So using the same expression here. So it means n of t is same as a r to the power of t. So it means if I need n of 5, that is the number after 5 years, it will be 10 times 2 to the power of t, that is 5. So which will give you also 320. So you can as well have it in such a way, because initially they were 10. After the first year, it will be 10 times 2. After the second year, 10 times 2 times again 2. Because this will again double. So which will give us this, which means after n years, it will be 10 times 2 to the power of n. So you will get the same answer. So conclusion, since 320 exceeds the threshold of 300 sheep, the old woman should give up rearing goats and concentrate on cows and sheep only as per her plan. That is another way. So those are two ways so far. You can use the geometric progression, but there you have to be careful. The 6 years term is the term which will have, which will give you the 5 years. Then for this one, you can manipulate it in this way by following this trend here. Or else you can simply track it in this way. Because the first year, initially they were 10. After first year, they will be 10 times 20, which is 10 times 2, which is 20. In the next year, it will be 20 times 2. Which will give us 40. Then 40 times 2, 80. 80 times 2, 160. 160 times 2. So this is at year naught. This is after the first year, the second year, the third year, the fourth year, and this will be the fifth year. So that is what we can as well use to obtain the answer directly without even applying the formula. So that is also another alternative way. So with this question here, you surely need to be careful. The vet told her that this breed multiplied at a common ratio of 2. So it was impressed and sort of how many sheep. The question is how many sheep. Okay? How many sheep she will be having after the 5 years. So they are not asking for the total number of sheep she will be having over the 5 years. So which means here we cannot use the sum. Here we cannot use the sum because they are not asking for the total number of sheep over the 5-year period. So what we are interested in is the population at that particular time, which is at the end of the 5 years. So that will be the required. Response to that part. So we look at the last part. So with that, for no one is left behind. Okay. So that is what we shall have there. So lastly, we shall talk about the future price of a sheep. The future price of a sheep. So they are telling us that is our next part. She has also been told that the price of sheep is in the next 5 years will be 3 times the sum of the modulus of the square roots of the complex number 1 plus I root 3 in hundreds of thousands. She wants to know what this price will be, and if it exceeds that, then she can take a loan now. So this is what we are told. She has also been told that the price of sheep in the next 5 years will be 3 times the sum of the modulus of the square roots of this complex number in hundreds of thousands. So she wants to determine what this price will be. And if it exceeds 800,000, then she can take a loan now. So our interest will be to find what the cost will be in the next 5 years. And we are given that we need to get the modulus. We need to get the modulus of the square roots of this. So we need to first of all get the square root of this, and after that we get their moduli. So can we look at that part? So let us look at that part there. So to determine the future price of the sheep using complex numbers. So this scenario will be testing you on how to find the square roots of a complex number. You can use the modulus argument or polar form and the moduli of a complex number. Then after that, you use these to compute the projected price and compare it against the loan threshold. Now, we have got 2 different ways of how we can get the square root of a number. One, you can use the polar form, which is the first one, or the next one, you can simply say, since you need the square root of 1 plus I square root of 3, since you need the square root of this, you can let the square root of this to be in form of A plus B to 3, like the way we did. Peter, please mute. So, get Peter, please mute. So let us begin by looking at one of the methods, and that is using the modulus argument form. So the modulus argument form, we shall need to first of all get R, and we get the theta. Then after that, we can obtain the next or the other roots by using the modulus and the argument that we shall have obtained. Now, let us look at how we can get the modulus. The modulus of this one is same as taking the square root of 1 squared plus the square root of 3 squared, and that will give us 2. Next, how do we get the argument? Now, you need to first of all plot that. It is always important. So you have 1, this is the real, and this is the imaginary. So this is where we have 1, and this is where we have root of 3. So it means the angle is in this quadrant. So this is where we have our theta. So our tan of theta will be same as root 3 over 1, giving us a theta as 60 degrees, and we can have that as pi by 3. So in radians, you can have it like this. In degrees, you can have it as this. Then it means our z will now be in form of r. R is 2 cos of theta. Theta is 60 degrees, then plus I sine of 60 degrees. Now you must be able to recall that if you have z to power 1 over n, that this is r to power 1 over n into cos of theta plus 2 pi k divided by n plus I sine of theta plus 2 pi k divided by n. So since we are looking at square root of z, we shall have z to power half, which is r to power half. R is 2 to power half into cos. The angle we have is 60. So 60 is pi. We saw that is pi by 3. Then plus 2 pi k divided by n is 2. Then plus I sine of pi by 3 plus 2 pi k divided by 2. So that is what we shall have. So that is what we shall have. But for these cases, we are looking at square root of a number. Our k will be equal to 0 and 1. K will be equal to 0 and 1. So for k equaling to 0, it means our first root, that is y naught, w naught. So w naught will be same as the square root of 2, this one here, into cos of pi by 3, because this is 0, this will be pi by 3 divided by 2 plus I sine pi by 3 divided by 2. Okay, now this is what we shall have. So you can go on and get w naught. So this will be the square root of this, square root of 2 into, okay, so what shall we have there? What is the cos of pi by 6? That is same as cos of 30. Okay, so we have a hand up. Yes, please. Yes, Michael. Yes, please. I see a hand. Is James? Yes, James.
I'm confused. Why have we decided to use k equal to 1 and 0 and 1?
We are looking at square root of a number. Our n is 2. If your n is 2, then k should be we need to let k so we can get 2 roots. And the k starts from 0, 1 up to n minus 1. So if your n is 2, your k will be 0 up to 2 minus 1, which is 1. If your n is 3, your k will be 0, 1 up to n minus 1, which is 2.
Thanks.
Welcome. So that is why we are taking that k. Now, that will be w naught. So you can go on and get for us that value. What value do you get? Cos of, if you get cos of pi by 6, because that will give us pi by 6.
It is 0.866.
Pi by 6. Pi by 6. That is cos of 30. Cos 30. So this is root 3 divided by 2. Then I sine 30. What do you get? Sine of that? (0.5).
Yes.
In other words, you will have this as root 2 into root 3 over 2. See? A half. This is what you will have. So if you put it back, this is W naught. So your W naught is same as root of 6 divided by 2 plus root 2. This is I plus root 2 over 2 I. So if you go on and get its magnitude, what do you get? The magnitude of this, it is same as root 6 over 2, which is squared, plus root 2 over 2, which is squared. So this will give us, this will be 6 divided by 4 plus 2 divided by 4 under square root. So this will give us 8 over 4 divided by 8 divided by 4 under square root, which is square root of 2. So magnitude of W naught will be square root of 2. We are getting the magnitude because from what we need, we need to get the sum of the moduli of the square roots of that complex number. And this is one of the square roots. This one here, W naught here, is one of the square roots. And its value will be that one there. Then the next process, this is when you use k equaling to 0. But you should also use k equaling to 1. So if k is equal to 1, you will get W1, which will be same as, so we are substituting in this expression. So 2 to power half will remain into cos. Now this is pi by 3 plus k is 1 plus 2 pi. You are dividing this by 3 plus I sine of the same pi by 3 plus 2 pi divided by, this is 2, divided by 2. So this will be 2 to power half into 2 to power half into, so get that one there. Pi by 3, that is 60. 60, you are adding there 180. And you are getting 240. You are dividing that by 2. Oh, you are adding there 280. Okay. So get 60. Pi by 3 is 60. And then 2 pi is 360. So that will give us 420. Divide it by 2. You should be able to get that one there, 210. So this is same as having a cos 210 degrees plus I sine 210 degrees. Or you can leave it in terms of pi. Here I have simplified that. But this is same as 210 divided by 180 times pi. So in radians, you should have it as 7 divided by 6. So you should have this as cos 7 divided by 6 pi plus I sine 7 divided by 6 pi. Okay. So when you get this one here, cos of 210 is what? Cos 210 degrees. I think you'll get the same thing. So this will be negative root 3 over 2. Then sine 210 will be negative 0.5. That is negative a half I. So it is the negative of this. So what you are getting as W1, is the negative of this. Is negative root 6 over 2 minus root 2 over 2I. Yes, James.
I have a question. Is there any other method of getting that we had cos 110 degrees? Any technique of having negative 3 out of 2, or it's a must have it in your head?
Which one?
Of obtaining root 3 out of 2.
Those are expressions you studied about angles. These are the, how do we call them, special angles. Sine 60, cos 60, sine 30, all those ones there. But even in the book of this book, the tables, the book of the logarithm book, they are there, those special angles. But of course, you must be knowing them. If you get like 0.866, that one is root 3 over 2. Should be knowing root 3, should be knowing their corresponding fractions to make it easier.
Okay.
Yes.
Thanks, teacher.
So W1 is simply the negative of what we have obtained there. So it means its magnitude will as well be square root of 2. So take its magnitude also, you have a square root of 2. And that will be the values for magnitude of W1 and magnitude of W2. So looking at that, you will get the sum of the magnitudes, and the sum of the magnitudes will be root 2 plus root 2, which will give us 2 root 2. And after that, after getting that, they told us from this scenario here that she also has been told that the price of sheep in the next 5 years will be 3 times the sum of the modulus of the square roots of the complex number 1 plus I root 3 in hundreds of thousands. Will be 3 times the sum of the square roots, the modulus of the square roots. So we have got the sum of the moduli as 2 square root of 2. So the price, the projected price in this period of time, in 5 years, it will be 3 times the sum of the moduli, and that is why we are getting 3 times that, and that will give us 6 root 2, and that value is in hundreds of thousands. So 6 root 2 is same as that, and when you multiply by hundreds of thousands, you should be able to get that value. Now you need to compare this value with this value, which is 800,000. So you realize that this value is actually greater than the 800,000. And if that is the case, then it means we can give the conclusion that since the projected price exceeds the 800,000, then it means the old woman can take out the loan now as per her stated condition. Because remember that she would take the loan if the amount exceeds 800,000. And we have seen that the amount exceeds 800,000. So it means she will take out the loan since the projected price exceeds the 800,000. So that is one way of doing that. But also another way, as I had said at the beginning, is that since you need to get the square root without using this one here, without using this, this is the polar form. You can simply do this. You can simply find the square root algebraically by letting, for example, W to be in form of A plus BI. So you will let the square root of 1 plus I square root of 3 to be in form of A plus BI. Okay? To be in that form. So it means that 1 plus I root 3 is same as this one squared when you square on both sides. A plus BI squared. So this is same as 1 plus I square root of 3, which is equal to A squared plus 2ABI. Then BI squared is same as minus B squared. So from here you have 1 plus I square root of 3, which is equal to A squared minus B squared plus 2ABI. Now from this given point, compare the real part alone and the imaginary part alone. So the real part will be A squared minus B squared is equal to 1. And the imaginary part, you equate that, so 2AB is equal to root of 3. Then solve these equations and obtain the values of A and B. So when you obtain the values of A and B, then you should as well be in position to get these values. Square root of 3 divided by that, and the square root of 1 divided by that, which we got root of 3 divided by square root of 2. I think that is what we got up here. Let us check. Okay, yes, that is what we had was root 6 over 2. But root 6 over 2, of course, that is same as this one here. Because if you have root 3 over root 2, when you multiply by root 2 both in the numerator and the denominator, you get root 6 over 2. So which is the same thing that we got. So you will also be able to get W naught as one of the roots as root 6 over 2. then plus 1 over root 2i, which is exactly what we obtained here, which is exactly what we had here. Because this is root 2 over 2. Root 2 over 2 is same as this. So that shouldn't confuse you. It's same as 1 over root 2. Because when you rationalize this, you will also be able to get root 6 over 2 plus 1 times root 2 both up and down. That is root 2 over 2i. So you'll get the same thing. So you can solve this one here, or you can use the this one here, the modulus argument form. So all the two should be able to give you the same answer. So with that, we should be able to look at the last part of item number 3. Should be able to look at the last part of item 3. So that should be able to mark at the end of our today's session. That should be able to mark at the end of our today's session. And unless there are questions, then we should be able to stop at this given point. So if you have moved with us up to this end, then I hope you have picked something. Okay. So that is so far 3 items done. So far 3 items done. And now we shall be remaining with only 2 items. And that should come in our next lecture and in our next sessions. So all these, please, if you need to go and revisit the same, you will be able to find all this at our YouTube channel. So please go and check. Yesterday we tried item 1. Today we have tried the 2 items. So please check out on our YouTube channel, so you can always refer in any case you get any challenges. So thank you everyone for attending. Let us meet in our next sessions.